Hi students, today we are going to see the session 2, one-dimensional wave equation, non-zero initial velocity. So previously we saw the one-dimensional wave equation with zero initial velocity. Next we will see the problem. A tightly stretched string with fixed endpoints x equal to 0 and x equal to L is initially at rest in its equilibrium position. If it's set vibrating by giving to each of its points a velocity lambda x into L minus x, find y of x comma t. So here initially they given a velocity is given. So the velocity is given means it is comes under the non-zero velocity problem because here the velocity is there. So previously initially at rest in its equilibrium position is given, that's at time t is equal to 0. So we know the one-dimensional wave equation. So from this we know the three possible solutions. So out of these three possible solution, we consider second one is the most general solution. Now we are going to frame the boundary condition. Y of 0 comma t is equal to 0. Y of L comma t is equal to 0. Next initial condition. So previously here we taken as dou y by dou t of x comma 0 is equal to 0. But here we are taken that is initial velocity is there. Initial displacement is 0. So y of x comma 0 is equal to 0. Dou y by dou t of x comma 0 is equal to f of x. What is our f of x? That is velocity is given lambda into Lx minus x square. So for all x belongs to 0 comma L. The suitable solution which satisfies above boundary condition is y of x comma t is equal to c1 cos px plus c2 sin px into c3 cos apt plus c4 sin apt. So now applying the first condition in equation number 1. So if you apply the first condition, what is the first condition? So y of 0 comma t is equal to 0. So this means we had to apply x is equal to 0. So if you apply x is equal to 0, that is the cos 0 value is 1. Here the sin 0 value is 0. So here no x term is having. So therefore, so from this we can understand C1 is equal to 0. So if you put this term is equal to whole term is equal to 0, the solution become a trivial solution. So in this case, only possible is we can put C1 is equal to 0. So therefore again the solution becomes y of x comma t is equal to C2 sin px into C3 cos pat plus C4 sin pat. So this is only our equation number 2. So now apply the second condition in equation number 2. So what is our second condition? Y of L comma t is equal to 0. That is we have to apply x is equal to L in this equation number 2. So we get C2 sin PL into C3 cos PAT plus C4 sin PAT. So here we have to find the which value is equal to 0. So already we said that this condition is this term is not equal to 0. And only possible here if we substitute C2 is equal to 0, the solution also will get the trivial solution. So only possible we can choose sin PL is equal to 0. So sin PL is equal to 0. So PL is equal to sin inverse of 0. Sin inverse of 0 value is n pi. So therefore P is equal to n pi by L. So we got the P value. So substitute the P value in equation number 2. So y of x comma t is equal to C2 sin n pi x by L, C3 cos n pi at by L plus C4 sin n pi at by L. That is, we are substituting the p value. So we got the equation number 3. So before next we have to apply the third condition. What is our third condition? Y of x comma 0 is equal to 0. Y of x comma 0 is equal to 0. So y of x comma 0 if you apply, see here we have to apply the t is equal to 0. So t is equal to 0 apply, then sin 0 value is 0, the cos 0 value is 1. So we got the result C2 C3 sin n pi x by L into C3 alone. C3 C2 sin n pi x by L equal to 0. So we already said that C2 not equal to 0. This case also not is equal to 0. So only possible is C3 is equal to 0. So if we substitute C3 is equal to 0 in this equation number 3, so this term alone will not come. So we get the C2 sin n pi x by L, C4 sin n pi at by L. The both combined C2 and C4 can be written as Cn sin n pi x by L into sin n pi at by L. So next we are going to apply the fourth condition. So before applying the fourth condition, So we have to differentiate that this one with respect to t. So therefore, summation n is equal to 1 to infinity. This is a constant Cn, right as it is. Then here also no t term is having. So this term is also right as it is. Then this term only we have a t. So differentiation of sinus will get the cos n pi at by L into differentiation of this term is we will get the n pi a by L. So that is only here written. So now apply after differentiation. Now apply the fourth condition in equation number 5. So what is our fourth condition? So dou y by dou t of x comma 0 is equal to lambda into Lx minus x square. So here apply t is equal to 0 if you apply. So the cos 0 value is 1. So remaining we get the summation n is equal to 1 to infinity Cn into n pi a by L into sin n pi x by L equal to lambda into Lx minus x square. So next we are going to find the Cn, this constant value. So for that we know the half range Fourier sine series in the interval 0, L is f of x is equal to summation n is equal to 1 to infinity bn sin n pi x by L. We know the formula for bn is equal to 2 by L integral 0 to L f of x sin n pi x by L dx. So now compare the equation 6 and 7. Cn is equal to bn, then f of x is equal to lambda into Lx minus x square. So now we are going to calculate the Cn value. So Bn is equal to Cn into n pi a by L. So after calculating the Bn value, so we have to cross multiply, we will get the Cn value. So Cn into n pi a by L equal to 2 by L integral 0 to L f of x sin n pi x by L dx. So we know the what is our f of x value? Lambda into Lx minus x square into sin n pi x by L dx. So using the Bernoulli formula, applying the limit, so we got the result like this. That is 4 lambda L square by n cube pi cube into 1 minus of minus 1 whole power n. So if you apply n as the even value, minus 1 the whole square, you will get the plus 1. So 1 minus 1, 0. So now if you give n is equal to odd value, that is minus 1 the whole cube is minus 1. Already outside have a minus, so minus into minus plus. So 8 lambda L square by n cube pi cube. So here n cube pi cube alone will come. Here have some mistake. Therefore, the most general solution is, so cross multiply that Cn value. That is the Cn what we have, n pi a by L. So cross multiply, we get 4 lambda L cube divide by n power 4 pi power 4 into a. That is only the here written n power 4 pi power 4 a. The most general solution is y of x comma t is equal to substituting the Cn value. So we get the result. Next we go to the next problem. A tightly stretched string with fixed endpoints x equal to 0 and x equal to L is initially in a position with the velocity v given by v is equal to y naught sin q pi x by L. Find the displacement y of x comma t in terms of the Fourier coefficients of f of x. Now we go to the solution. See, listen. So here the length of the string is given x equal to 0 to x equal to L. And initially the velocity is also given v is equal to y naught sin cube pi x by L. So here also initial velocity is given. So therefore it comes under the non-zero initial velocity. So this and all we know. Now we are going to write the boundary conditions. Y of 0 comma t is equal to 0. Y of L comma t is equal to 0. Next initial condition, y of x comma 0 is equal to 0. Dou y by dou t of x comma 0 is equal to f of x. That is the velocity is equal to y naught sin cube pi x by L. We know the general solution y of x comma t is equal to c1 cos px plus c2 sin px into c3 cos pat plus c4 sin pat. So after applying the condition 1, 2 and 3, so we get the y of x comma t is equal to summation n is equal to 1 to infinity cn sin n pi x by L into sin n pi at by L. Now we are going to apply the fourth condition. So before applying the fourth condition, we need to differentiate this equation 4 with respect to t. So this term keep as it is. Only differentiate this term. So cos n pi at by L into n pi a by L. Next we differentiated. Next we are going to apply the condition number 4. So dou y by dou t of x comma 0 is equal to f of x. So summation n is equal to 1 to infinity Cn n pi a by L into sin n pi x by L equal to y naught sin cube pi x by L. So now we are going to calculate the Cn by using the half range Fourier sine series in the interval 0, L. We know the half range Fourier series is f of x is equal to summation n is equal to 1 to infinity Bn sin n pi x by L. We know the formula for Bn. Bn is equal to 2 by L integral 0 to L f of x sin n pi x by L dx. So comparing equation 677, so we know that Bn is equal to Cn, f of x is equal to y naught sin cube pi x by L. So here is substitute, C is n. So comparing both the sides, if you expand the summation, n is equal to 1. So b1 sin pi x by L, next plus b2 sin 2 pi x by L, etc. So here we have to use the sin cube formula, the sin 3x formula. We know the sin 3x formula is 3 sin x minus sin 3x by 4. Substituting here, so comparing the both the sides, so we can write b1 is equal to, what is the b1 coefficients? 3 y naught by 4. The next b2, so here the b2 term is missing, that is the 2 pi x by L term is not having. So only we have a 3 pi x by L. So b3 value is equal to minus y naught by 4. So we got the value, b1 value and b3 value. The remaining b2 value 0, b4 value 0, etc. All the values 0. So comparing the like coefficient, we get b1 value and b3 value. So bn is equal to 0 for n naught is equal to 2, 4, 5, 6, etc. Then therefore, the most general solution is y of x comma t is equal to c1 sin pi x by L into sin pi at by L plus c3 sin 3 pi x by L sin 3 pi at by L. So here substitute the c1 value 3 y naught by L into L by n pi into this remaining term as it is minus y naught by 4 into L by 3 pi a into sin 3 pi x by L into sin 3 pi at by L. So this is only our displacement of y of x comma t.